Okay, now what we want to do is hook up a basic control relay circuit. The first thing about hooking up a control relay circuit is we have to know at what voltage the control relay is going to activate. And in this case, this control relay will operate at 12 volts. Now, we're going to use a basic, normally open push button to control the coil on this relay. Good common practice or hook up the control relay's coil first. This way you can separate out the control circuit from the power circuit. So I'm going to hook up to my 12 volt power source here, and I'm going to run my positive to the common on my normally open push button. Then from there I will go from my normally open terminal to one side of my control relay's coil. Now the coil on this control relay are the two middle ones. You're not going to be able to know that unless you follow the schematic that was shown to you in this circuit. So then once I have my positive hooked up to one side of my coil, I need to complete that circuit by hooking up the negative to the other side of the coil. Now, if you think of the coil in this control relay as a resistor and just a basic load for the control circuit, it really is nothing more than hooking up a simple switch and a simple load. Now, once you have this hooked up and your power is turned on, what you always should do is push the button to listen for the click. That click right there indicates that your control relay is hooked up correctly. This is a very, very important sound for industrial electricians because this is one of those sounds we can help to distinguish between is the problem in the control circuit or the power circuit. So again, I push the button, I hear the sound. Now if I were to hook this up wrong and wire this switch up normally closed, I would still hear the click, but it would be the click from it turning from normally closed, from being on to being off. And so we don't want to do that. And you'll always know if that's true because what will happen is if you hook it up to the normally closed and you turn your power on, you'll hear a click right away. Whole relay circuit hooked up on the control side, we can now test the switches that this electromagnet is going to be controlling. To do that, we want to perform a basic continuity test. So I'm going to turn my meter on. I'm going to set it to ohms. I want to take my selector switch, my range selection, and turn it all the way down. Hook my meter up here to here. My meter leads to here. Now, what I want to do is I want to take one of my wires and hook it up to the common. The common of this control relay is either port on the bottom. Okay? So that's why we always want to make sure these arrows are down, not up, because if not, you're going to install your relay completely upside down. So we want to make sure that the arrows are on the bottom portion of the relay and that we hook for our common here or here. Either way, doesn't matter. Now the first one we want to test is the normally open. And the normally open is on the top left of the control relay. So right here. Now, if you notice, my continuity is indicating infinite. This is the infinite symbol for this meter. When I push the button, I am now getting a reading that's less than 1 ohm, which is really good because we want our continuity to indicate continuity, not a high resistance. So this shows us right away, all right, I'm getting continuity when I push the button. What that means is the normally open switch contact right here is closing from common to normally open when my coil is activated from my control side of the circuit. Now, I want to test my normally closed. My continuity test for my normally closed should be the exact opposite that it was for my normally open. What that means is I'm not pushing the button, but yet I still have continuity. When I push the button, that continuity goes away, and I get infinite, which means no electrical connection between my common and my normally closed. What that says is my normally closed has now opened. I let it go, it goes back to the closed position.